In the vast expanse of our solar system, countless objects hurtle through space in their cosmic dance around our sun. Most go unnoticed, silently passing by as they have for billions of years. But occasionally, one of these celestial wanderers captures our attention and sometimes our concern. Recently, astronomers have been tracking a massive asteroid on what appears to be a trajectory, bringing it unnervingly close to Earth. But should we actually be worried? I'm Alex McColgan, and you're watching Astrum. Today, we're going to explore what we know about this approaching space rock, what the actual risks are, and how humanity has prepared for such cosmic encounters. The asteroid in question, designated 2023 DW, was first spotted in February 2023 by astronomers at the Purple Mountain Observatory in China. At approximately 50 meters in diameter, about the size of an Olympic swimming pool, it's not the largest asteroid we've encountered, but it's certainly substantial enough to cause significant damage should it impact our planet. When initially discovered, preliminary calculations suggested a slim possibility of impact with Earth in 2046, sending ripples of concern through the scientific community and beyond. But as with many potentially hazardous asteroids, the story is more complex than initial headlines might suggest. To understand the true nature of the risk, we need to appreciate how astronomers track and assess these cosmic visitors. When a new, near-Earth object is discovered, its initial orbital calculations are based on a relatively small number of observations over a short period. This creates what scientists call an uncertainty ellipse, essentially a region of space where the asteroid might be at any given time in the future. The more observations we make, the smaller this uncertainty becomes, and the more precisely we can predict the asteroid's path. It's one of life's little ironies that the very announcements that generate headlines about potential impacts are almost always followed by reassuring updates as more data comes in. And that's exactly what happened with 2023 DW. After several weeks of additional observations, astronomers were able to refine their calculations, dramatically reducing the probability of impact. What initially appeared as a 1 in 600 chance of striking Earth has now been downgraded to approximately 1 in 770,000. To put that in perspective, you're about 30 times more likely to be struck by lightning in your lifetime than Earth is to be struck by this particular asteroid. The laws of celestial mechanics are unforgiving, but in this case, they're working in our favor, as the asteroid is now expected to pass safely by our planet, missing us by millions of kilometers. But what if, and this is purely hypothetical, at this point, an asteroid of this size were to impact Earth? The consequences would depend greatly on where it hit. If it struck an ocean, which covers about 70% of our planet's surface, it would generate tsunamis that could devastate coastal regions. If it hit land, it would create a crater roughly 1 kilometer in diameter and release energy equivalent to about 10 megatons of TNT, several hundred times more powerful than the atomic bomb dropped on Hiroshima. The resulting blast wave, thermal, radiation, and debris ejected into the atmosphere would cause severe local destruction, but would not trigger global catastrophe. For comparison, the asteroid that formed the Chicxulub crater and contributed to the extinction of the dinosaurs was approximately 10 kilometers in diameter, 200 times larger than 2023 DW. That impact released energy equivalent to 100 million megatons of TNT, ejecting so much dust and debris into the atmosphere that it triggered a global impact winter that drastically altered Earth's climate. The asteroid we're tracking today, while significant, simply doesn't have that level of apocalyptic potential. This isn't the first time we've tracked potentially hazardous asteroids, and it certainly won't be the last. In 2004, astronomers identified Apophis, a 370-meter asteroid, and initially calculated a 2.7% chance of impact in 2029. the highest probability ever assigned to an object of its size. For a brief period, Apophis reached level 4 on the Torino scale, a system designed to categorize the impact risk of near-Earth objects. However, as with 2023 DW, additional observations allowed for more precise orbital calculations, and we now know Apophis will safely pass by Earth, missing us by about 32,000 kilometers, closer than many of our artificial satellites. The story of Apophis highlights something crucial: our improving ability to detect and track potentially hazardous objects. Decades ago, an asteroid like 2023 DW might have passed by Earth completely unnoticed. Today, we have multiple survey programs dedicated to finding near-Earth objects, including NASA's Center for Near-Earth Object Studies and the International Asteroid Warning Network. These programs have identified over 95% of asteroids larger than 1 kilometer that could potentially cross Earth's orbit, the ones capable of causing global catastrophe. And they're constantly working to detect smaller objects too, like the one we're discussing today. But detection is only half the battle. The more pressing question might be, what would we do if we identified an asteroid genuinely on collision course with Earth? Unlike in Hollywood disaster movies, we wouldn't immediately launch nuclear weapons. That could potentially create multiple, smaller, but still dangerous fragments on the same trajectory. Instead, scientists have been developing more controlled approaches to asteroid deflection. In 2022, NASA conducted the first real-world test of planetary defense technology with the Double Asteroid Redirection Test, or DART mission. The spacecraft deliberately crashed into Dimorphos, a small asteroid moonlet orbiting the larger asteroid Didymos. The impact successfully altered Dimorphos's orbit around Didymos, demonstrating that we could potentially deflect an asteroid headed toward Earth, given enough warning time. The European Space Agency is planning a follow-up mission called Hera to thoroughly investigate the effects of the DART impact, providing crucial data for future planetary defense strategies. Other proposed deflection methods include gravity tractors, spacecraft that would fly alongside an asteroid, using their gravitational pull to slowly alter the asteroid's course over time, and solar sails, which would use reflective material to direct solar radiation pressure against the asteroid, gradually changing its trajectory. These methods might sound like science fiction, but they're based on well-established physical principles and represent viable strategies for addressing potential impacts, especially if we have years or decades of warning. That's why early detection is so crucial. The more advance notice we have of a potential impact, the less force we need to apply to divert the asteroid's path. A nudge of just a few centimeters per second, applied years in advance, can translate to a missed distance of thousands of kilometers by the time the asteroid reaches Earth's orbit. It's like the cosmic equivalent of steering a boat. A small adjustment early in your journey can mean the difference between reaching your destination safely or running aground. What's particularly fascinating about asteroids is that while they represent one of the few genuine existential threats our planet faces, they're also time capsules from the early solar system, preserving chemical and physical conditions from when our cosmic neighborhood was forming 4.6 billion years ago. Some scientists even speculate that asteroids and comets may have delivered the water and organic compounds necessary for life to develop on early Earth. So these objects that could potentially end civilization might also have been crucial to its beginning, one of the universe's great ironies, and despite their destructive potential, impacts are extraordinarily rare events on human timescales. The last asteroid to cause significant damage was the Tunguska event in 1908, when an object approximately 50 to 60 meters in diameter, similar in size to 2023 DW, exploded in the atmosphere over Siberia, flattening about 80 million trees over 2,150 square kilometers. Had it occurred over a major city, The destruction would have been catastrophic, but it happened in one of the most remote regions on Earth, resulting in no confirmed human casualties. More recently, in 2013, a smaller asteroid approximately 20 meters in diameter exploded over Chelyabinsk, Russia. The shockwave shattered windows and damaged buildings, injuring about 1,500 people, primarily from flying glass. This event served as a wake-up call for many in the planetary defense community, highlighting that even relatively small objects can cause significant damage, and that we might have very little warning for asteroids approaching from the direction of the Sun, where our detection capabilities are limited. So, returning to our original question, should we be worried about 2023 DW or other near-Earth asteroids? The answer is nuanced. We should be concerned enough to continue investing in detection and deflection technologies, but not worried about any imminent apocalyptic impact. The current asteroid poses virtually no risk, and even for future potential impactors, we're better prepared than ever before in human history. What's remarkable is that we're the first generation of humans with both the technology to detect potentially hazardous asteroids and the capability to potentially do something about them. Our ancient ancestors witnessed comets and meteor showers as mysterious omens beyond their control. We understand them as natural phenomena that, while potentially dangerous, can be predicted and possibly mitigated through scientific advancement and international cooperation. This shift in perspective represents one of humanity's greatest achievements. Our gradual mastery over natural forces that once seemed entirely beyond our influence. We've moved from being passive observers of the cosmos to active participants, capable of altering the very orbits of celestial bodies when necessary for our survival. It's a responsibility we should approach with appropriate humility, but also with confidence in our collective problem-solving abilities. So, while sensational headlines about approaching asteroids might generate clicks and views, the reality is far less alarming than often portrayed. We're tracking this space rock, and thousands of others, with increasing precision. We're developing technologies to protect our planet if needed. And we're expanding our understanding of these ancient wanderers that share our solar system. That's not to say we should become complacent. The universe occasionally sends reminders of our vulnerability, like the unexpected 2019 OK asteroid that passed within 65,000 kilometers of Earth, with just 24 hours' notice. Events like these underscore the importance of continued vigilance and improved detection systems, particularly for smaller asteroids that are harder to spot but can still cause regional damage. Looking ahead, organizations like NASA and ESA are developing new asteroid hunting telescopes, including the NEO Surveyor mission, specifically designed to find potentially hazardous objects. International cooperation on planetary defense continues to strengthen, with regular tabletop exercises simulating potential impact scenarios and coordinating global responses. So, as 2023 DW continues its journey through the solar system, safely, past Earth, we can appreciate it as a reminder of both cosmic hazards and human ingenuity. We're standing at a unique moment in history where we can not only comprehend the complex orbital dynamics of these ancient space rocks, but potentially alter them if necessary. It's a capability worth celebrating, even as we remain vigilant against future cosmic threats. I'm Alex, and this has been Space Truths. If you enjoyed this exploration of asteroid impacts and planetary defense, please consider supporting the channel through Patreon. Your contributions make videos like this possible and help us continue exploring the wonders and mysteries of our universe. Until next time, keep looking up, but don't worry too much about what might be falling down.